Okay, let me see. So I have to admit I didn't have the time to look for the JSON myself. I'm on the site BTC Threads right now, and they have a very nice tutorial also about how actually the blockchain info API works. So if you are interested to go further deeper into it, you can also have a look at this website. But what I'm showing right now is the JSON of a Bitcoin block. So yeah, I think you know JSON. It's like a representation format, kind of like XML. You first have a key, which is in this case the hash, and you have a value.
Is it possible for you, Felix, to zoom in a little, unless it's
Of course.
unless it's secret code? Yeah, that's now it's showing up on my screen as well. Perfect.
Okay, awesome. So yeah, you have a hash, a key, and the value. So the header or the first entry of a block is always the hash of the block. So you basically use all the data of the block itself, and you do a hash of it, which is this kind of hash. But one thing which is remarkable about the hash is that it's starting with a lot of leading zeros. And this results because of the mathematical riddle. The mathematical riddle is actually to calculate hash values. And you do this by taking a block, or taking the block that you want to publish, and calculate, like you have all these values, and what you do is calculating the nonce. So the nonce, or the nonce, is the solution of this mathematical riddle. If you hash this block with the nonce, you will receive this hash. And the idea of the whole mathematical riddle is to solve a minimum amount of leading zeros. So if you want to make the mathematical riddle easier, you say, okay, we just take, I don't know, 6, 7, or 8 zeros, and it will be much easier to solve the mathematical riddle. If more computer power gets added, you will have more leading zeros, and therefore you need more computer power to solve a block in the same time. So that's basically the whole magic behind the adjustable block solving time. So yeah, that was the first value. Now the second one is just a version. As Griff already said, the blockchain or Bitcoin, the whole system, it's upgradable. You can actually go into GitHub and look for the source code of Bitcoin. You can check it out and deploy your own blockchain if you want to. Yeah, the next thing is the previous block. So this is the pointer to the hash value of the predecessor of the previous block in the blockchain. So this is the pointer all the way back to the first block, which is also called the Genesis block. Then we have a thing called Merkle root. The Merkle root is a hash value of all the transactions. It's a defined algorithm. It's also called hash root at some points. If you're interested, just look it up on Wikipedia, is what I'm saying right now. But it's a hash value of all the transactions, and you can use this to have an easy verification if a transaction is actually included in a block. Okay, then we have a time, which is a timestamp. Bits is kind of telling how difficult it is to solve the block. And there's the fee, which is basically the fees that, if I'm right, it's the fees that have been paid in the transactions. Griff, please tell me if I'm wrong at this point.
Looks good to me. I'm not sure about bits, but fees for sure. There's something really interesting with the way Bitcoin works. I'll just go, it's kind of an aside on fees, that when somebody makes a fee, the fee is not explicit. You have these things called unspent transaction outputs that are basically every unsigned everybody's balance is kind of this addition of unspent transaction outputs. And when you send a transaction to somebody, like let's say I have an unspent UTXO that has, UTXO that has 1 Bitcoin in it. When I want to send 0.6 Bitcoins to somebody, I actually split that up into 2 UTXOs, zero point 0.6 and then 0.39 something, right? Because the fee is almost implicit in the way it works. It's kind of interesting. I don't know. And so then the miners, at the end, they collect all the outputs and all the inputs and subtract them, and then you get that fee.
Cool. Great.
Awesome.
So just interrupting a little in the going through, we'll hear the last things. But Griff just asked here on Messenger, or encouraged all of you hardcore audience still left, that he would like to stay on speaking with you. So when Felix is done unpacking this block here, I think we'll unmute everybody. So it's very easy for you to administer when you want to speak. It's just to click your mic on and off, so to speak. So we'll try to control it. But Felix, are there still some tags here to be explained, or are we getting there?
Well, there's some text left, but they're not that. They don't take that long anymore.
Yeah.
So I already actually explained the answer, which is the solution, what you had to calculate for this block. Then you can see the number of transactions included in the block. So 153 transactions have been made in this one block. Yeah, the size in bytes. The block index, so we're at block 346,358. And this tag is quite nice, which is if it's the main chain. So it's actually being calculated afterwards because, as I told, if 2 people are solving the next block at the same time and are publishing a valid block, you will have 2 chains. And one of those chains only can win. So this tag just shows you if you're on the right chain or if you're on one of those chains that have been split. Then we have the height. Now I have to think, what was the difference between the block index and the height?
It's okay, I think.
Okay.
I actually thought the height was the block number, and I'm not sure what the block index is.
Yeah, I think actually the height is on which block we are right now. And block index is probably including the splitted chains.
Great.
Okay.
Are we there?
Yes, then we're there. The last part is just the transaction itself. Yeah, I think we don't need to explain this.